Namaskar. In the previous video, we had observed the image formation due to the convex lens. Now again, if I will have to consider the image formation due to the concave lens, this lens, then again there are 4 points which are important. One is F, another is 2F. To the left side, similarly here it is F, here it is 2F. This is the pole of a lens, O. Now what about in case of a concave lens? I can think about different positions. Suppose the object is at infinity, the rays are parallel to each other, and I know that after passing through the concave lens, they diverges away from each other and they are supposed to be emerging from a point which is known as the focus. Correct? They are supposed to be emerging from the point. Therefore, I will skip this image formation. If the object is at infinity, image will be at F and it is obviously virtual. Actual rays are diverging away from each other. They will not meet each other at any point, but they are supposed to be diverging from this, and therefore this can be treated as the position of virtual image. Now, I will skip this infinity point and I will bring it here. Suppose the object is in between infinity and 2F. In between infinity and 2F. That means somewhere here. What happens in case of the concave lens? For that, I will treat the object of 1 centimeter. It is O dash. Lens is here. Actually, there is need to draw this lens something like this, but I will not draw every time. I will assume that the lens is here. This is the pole of a lens O. This is F. This is F. This is 2F, and this is 2F. Now, what I will have to do? I will have to draw a parallel line parallel to the principal axis. Correct? Parallel to the principal axis. And after passing through the lens, the light or the ray is supposed to be emerging from supposed to be emerging from F. Therefore, it travels like this. This will be the emergent ray. This will be the emergent ray. And another ray, suppose it is traveling towards the pole of a lens. This is pole of a lens. Then it travels undeviated. In the last video, I have told you that in standard 9 or 10, I remember my teacher Sati sir has told us or teach us that these two rays are important. In case of a lens, the parallel ray, in case of convex lens, passes through the focus, or in case of concave lens, supposed to be emerging from the focus, and the ray traveling towards pole travels undeviated in convex as well as in concave ray. And therefore, you will observe that these two rays will never meet each other, but they are supposed to be emerging from a common point. I will have to extend this ray in reverse direction, and I will observe that one real ray and one virtual, which is they meet each other at this point, and therefore this point can be treated as the image. It is I dash. You will observe that this image is virtual. Therefore, again the I is essential. I is necessary to observe this image. Obviously, it is diminished. That means in case of a concave lens, if the object is beyond F, beyond 2F, the image will be in between F and pole, and it is diminished, it is virtual, it is not inverted, it is as it is. Now I will keep the object at 2F, correct? Here I will keep the object at 2F, correct? Okay, it is of 1 centimeter. Again, now it is very simple. I will have to draw a line parallel to the principal axis. It is the ray parallel to the principal axis. After passing through the lens, it is supposed to be emerging from. Therefore, I am connecting this and this point, but drawing the line beyond the lens, after the lens. Whereas I will have to extend it in reverse direction, correct? I will have to extend this in reverse direction towards the focus. Therefore, this is the situation. And the ray which is traveling towards the pole, this is the pole, travels undeviated, correct? Travels undeviated. Therefore, again, if the object is at 2F, image is virtual, I dash. It is the intersect between the ray which is traveling towards the pole and extended ray after reflection which is parallel to the principal axis, correct? It is supposed to be emerging from this point, and therefore this is the image. If the object is in between 2F and F, therefore I will have to consider this is 2F is greater than U is greater than F. where u is the object distance, and therefore in word I can say that the object is in between 2f and f, but in mathematical equation I can write 2f is greater than u is greater than f. This is the pole of the concave lens. I will have to remember I am preparing the diagram for ray diagram for the concave lens. Therefore again I will have to draw the parallel ray. After passing through the lens, it is emerging from, supposed to be emerging from the focus. Therefore this is dotted line, and here it is solid line. This is the actual ray. And the ray which is traveling towards the pole travels undeviated, correct? Travels undeviated. Therefore this is the ray, correct? This is the ray. And here there will be the image. Here there will be. Now you may carefully observe that slowly the image is traveling towards the pole. If the object is at infinity, it is at the focus. If the object is slightly ahead near to 2f, the image has displaced slightly. If the object is at 2f, there is a slight deflection or change in position of the image. If the object is in between 2f and f, it is moved further. Now we will discuss this again. Suppose my object is at f, correct? This is the focus and object is at focus. The lens is concave lens. Therefore the ray which is parallel to the principal axis, I will have to draw the ray which is parallel to the principal axis. After passing through the lens, it is supposed to be emerging from the focus. Therefore up to this point it is dotted line, then there is solid line. And the ray which is passing traveling towards the pole travels undeviated. Therefore here I will have to draw the ray something like this, and this will be the image, correct? This will be the image I dash for this object O dash, correct? And finally, if I think about the object, if it is in between f and pole, therefore it is if it is f is greater than u is greater than 0, here I will have to say that it is at f, correct? Here it is at f. Then again what I will have to do, I will have to draw a parallel line, correct? Parallel line parallel to the principal axis, and the ray which is parallel to the principal axis, after passing through the lens, supposed to be emerging from the focus. Therefore up to this point it is dotted line, and then there is solid line, correct? It is supposed to be emerging from the focus. And the ray which travels towards the pole travels undeviated, correct? Travels undeviated. It is something like this, and this will be the position of I dash, that is O dash is the object, correct? Now if I draw a similar diagram for the object which is very much close to the lens, very much close to the lens, correct? This is the position, say for example. Then again the ray which is parallel to the principal axis, after passing through the lens, supposed to be emerging from the focus. Up to this it is dotted line, then there will be a solid line. The ray which is traveling towards the pole travels undeviated, and you will observe that this will be the position of image. Means two conclusions can be drawn. As the object from infinity moves towards the pole, there is a shifting of image towards the pole. This image has been shifted towards pole slightly. Image slightly towards pole, slightly towards pole, slightly towards pole. But the rate at which the object is moving towards the pole and the rate at which image is moving towards the pole are not same. And therefore the distance between object and image also goes on decreasing. Distance between object and image, distance between object and image, object and image, object and image, object and image, and finally object and image. And there will be a particular point at the end. It may be the pole itself where the object and image lie on each other. Now most of the time the convex lens is used for the formation of image. Therefore such type of diagram for the concave lens is rarely needed, but you may need the diagram for convex lens so many times, typically for the simple microscope, for the compound microscope, for the telescope, for the eyepiece. What are the different cardinal point for eyepiece? What is eye lens? What is the object lens, etc. And therefore, it is better to have the practice of drawing the ray diagram for convex lens more rigorously, more frequently, and once, at least once, you will have to draw the diagram for the concave lens. Thank you.